Okay, this is our marathon problem. This is you want to target this rigor as you prep for the test. So a lot going on here. So what we have is sine alpha is equal to the ratio 5/13. Cosine beta is equal to the ratio of -4/5. And this expression right here is also restricted. So this compound inequality you're looking at here reads 0 is less than alpha, which is less than pi/2, which is less than beta, which is less than pi. So what does that mean? So it means that alpha right here between 0 and pi/2, this is a quadrant 1 angle. Right? That's important. And then what does beta mean? Well, this means it's a quadrant 2 angle. Right? So think about that. Quadrant 1, sine and cosine, always produce positive ratios. Everything's positive in the first quadrant. However, in the second quadrant, cosine is negative, sine is positive, right? So we got to keep that in mind. And we're asked to find cosine alpha minus beta. So let's expand this formula, right? So it's going to be cosine alpha, cosine beta. The operation is going to change to a positive. Sine alpha, sine beta. Let's look at what we have, right? So here I have sine alpha and cosine beta. I have these values. So I have this value, cosine beta. I have this value. I do not have cosine alpha and I do not have sine beta, and I need to find them. We're going to use information right here to help us figure that out. So let's work with alpha first. Okay, so right now I know I have sine of alpha is 5/13. Remember, sine measures your y over your r or your opposite over your hypotenuse, depending on how you kind of work with this information. So I'm going to sketch an angle in the first quadrant, an arbitrary angle that I'm going to label as alpha right now. So let's say this is alpha. I'm going to create a reference triangle for myself. And I know that the sine of alpha from this information right here is 5/13, which means my hypotenuse or radius is 13 here. And it also means my opposite or y value is 5. Okay. If you know your Pythagorean triples, then you'll know the long leg of this right triangle. And if you don't, then you can use Pythagorean's theorem, right? So that's 13 squared equals 5 squared plus x squared. Solving that lets us know that x in this case is positive 12. Now that I have that with respect to angle alpha, I can now find cosine of alpha, right? Remember, cosine of alpha or cosine of any angle for that matter is equal to the x over the r or the adjacent over the hypotenuse. Okay, so in this case, if I'm looking at alpha, the cosine of alpha is going to be 12/13. And I'm also going to record the sine of alpha just to have next to it right now. So the sine of alpha was 5/13. Now I'm going to move over and deal with my other function. So that was sine alpha. And then the other value that I have is cosine beta, right? So cosine beta right here is equal to -4/5. So we'll start with that. Keep the negative in the numerator in this case. You don't want the denominator to hold the negative sign. So cosine beta, again, is x over r or adjacent over hypotenuse, however you want to view it. I'm going to sketch my information. So again, second quadrant angle right now, right? So here is a second quadrant angle. This is the angle beta I want to work with right now. And I'm going to draw my reference triangle. So I made my vertical in green because it's a positive value. I made my horizontal in red because it has to be negative. We're in the second quadrant. So cosine beta is -4/5, so my hypotenuse or radius is going to stay 5, and then my adjacent side, or x, is going to become -4. Again, Pythagorean theorem lets us find the green vertical, or the y, or if you know your Pythagorean triples, this is a 3, 4, 5 triangle. It's +3 right there. I have cosine beta, I want sine beta. So sine beta is, if you remember, y over r, or opposite over hypotenuse, however you want to view it. So in this case, the sine of beta is going to be 3/5, positive. You really need to pay attention to those positive, negative signs when you're doing this, because if you're not paying attention to what quadrant you're in, your ratio could be labeled as the wrong positive, negative sign, and that's going to hurt. So we have sine beta is 3/5, and we started with cosine beta is -4/5. Almost there. So I needed these 4 trig values before I can get through this problem. Let's go back up and look. I'm trying to evaluate this right here. So cosine alpha, cosine beta, plus sine alpha, sine beta. I'm going to take this and I'm going to take it all the way down so I don't have to rewrite it. And now I want to evaluate this. I'm just kind of plugging our values in. So let's see. Cosine alpha we know is 12/5, 12/13, excuse me. Cosine beta is -4/5. Plus, and then sine alpha, so sine alpha is 5/13. Sine beta is 3/5. This is just simple simplifications. So on the left side here, -48 over 65 plus 15 over 65 again. Condense, combine, -33/65. This is our answer. So this is, I believe it was cosine alpha minus beta to begin with. Let's go back up and just double check. Cosine alpha minus beta. Good. So this is our target. We want to get to this rigor comfortably. Don't skip these problems. Non-calc. You notice we didn't use a calculator at all. You really can't fake your way through it without a calculator, or with a calculator. It's pretty clear. And that's it. This problem.